else drops in, but we can get going.
Devin, is Devin around?
Devin, feel free to ping him, Doug, if you want.
That.
Perfect. Does anyone want to volunteer to go first?
I guess, yeah, I'll start it off.
Go for it.
I haven't really been doing, or I've been kind of playing around with the fields object there on the MT. Yeah, I'm just trying to find ways to parallelize it, or the calculation of the fields. I'm actually finding that when I'm doing it in parallel, it's not that much faster. It if you solve it in sequential, yeah, it's quick. It takes like 5 seconds to solve. Whereas if I'm just parallelizing with DAX, or sorry, Dask, I'm only getting like a couple, like maybe 10% speed up. Maybe it's just the way that if I can assign the processors or the cores a little bit differently, maybe it'll speed it up a bit. I also been looking at trying to use X-array instead of a dictionary for the fields. I've got that implemented. I just got to look into it a little bit more and just see how to, so that we don't really have to change the field object too much. It'll just look and see if it's a dictionary or if it's an X-array, and then it'll know what to do when you call for the fields. Yeah, so that's all I've been working on right now.
Cool. Yeah, I wonder if with the parallelization, because I think right now the fields object, one of the main bottlenecks is actually all of the reshaping and like the initialization of the fields object.
Yeah.
Yeah. Have you pushed this on a branch somewhere?
Yeah, it's simulation MT.
Okay, cool.
Yeah, it's the start of it there.
Okay.
Yeah, just playing around, just trying to see what we can do to make it a little bit easier. And if we can delay the fields object, like just say the X-array, delay that, then we can calculate on the fly. And I did some tests with calculating the fields on the fly, and yeah, it's super quick. It works really well.
Excellent.
So yeah, if we can just find a way to delay it, yeah, should be good.
Thanks, John.
Where are you working again, John?
Simulation MT.
And you've pushed?
Yeah.
All right, I'm gonna take a quick look.
Don, would you like to go next?
Yeah, I can. So the pull request that I created last week for the surface to end topo on discretize. So I created a new test. I kind of moved the test that was in SimPEG and augmented it. So the pull request is ready for review. It passes everything. Just need someone to approve it. And then I expanded it for all meshes, so it should work for tensor, octree, cylindrical, and from 2D to 1D, from 3D to 1D. So I think we're pretty covered there. So I would think if this goes into discretize, we should just try to just change all the code in SimPEG that uses the surface to end topo currently in SimPEG and just reroute to the discretized version and throw a warning, you know, because I renamed it to something more, something a little bit better, I think. So yeah, we can cross that bridge once you guys bring it in.
Just need to look over it. I'm sure it's fine.
Cool. Thanks, John. Joe, would you like to go?
Sure. So we're doing work on getting the simulation branch going again, and we're working towards that. So most of my goal has been like trying to fix all of the little things that I wanted to get changed about. One of the things that I implemented was on PyMat solver. So instead of tying in the fields or in like the simulation routines, you guys were setting tasks, like using with the Dask step, you were setting the number of threads and number of CPUs for the as part of the simulation. when you like, it seemed like it had been meant to be just for the solver, like to use the solver to be used that many. So instead, I enabled it to be like a solver option that you can use, so it's not tied to the simulation class. It's tied to the as a solver option. It took a little bit of thinking to get that working for the Paradiso solver, because the way that the set MKL number of threads works is it sets it for all of MKL processes. So every time you call it, it sets it for every MKL process that gets called. So it's more of like a global property than something that's local to each, that would be local to each solver object itself. So I had to think a little bit, I had to implement it in like a global way in terms of the Python solvers. So now it's, so if you see a little bit of weirdness in there, that's why. If you start looking through it, if you want to look through the pull request, I created one. The other part of that is so is anyone here using the mumps solver? I'm seeing a lot of head shaking now. Basically, it's hard, like we're not getting tests passing properly on Travis and things due to mumps usually failing. And what I'd like to do is remove that part of the solver interface in PyMat solver for now. And we're going to be working, I'd like to work towards getting Python interfaces to the mumps package through CondaForge, because it is available through there and it makes it a lot easier to install on Windows, Mac, Linux through CondaForge. So I'd like to have Python interface to that specific package that we can use and hopefully get some more options. And I'd also, in the future, like to get a Python interface to the Paradiso solver and expose more of the options that Paradiso has to Python, so we can hopefully optimize with the solver a little bit better and use that and take advantage of some of these little parameters that we can tweak. Because right now there's not really much you can optimize with the Paradiso solver. Not many knobs you can turn right now with it. So I'm working towards that. What else? Oh, I started to try to split off some of the Dask stuff that was in DC in the simulation class. It's on like if you want to see what I'm doing, kind of, I've got a few things. I don't think I've pushed any of my changes to it yet, outside of incorporating all the stuff that all the push that Dom did to remove the delaying of fields. So I just bumped that up with simulation, because it was going to be a better way. Because what I had noticed is that working with fields options, if you didn't know it was going to be a delayed function, so let's say you asked for all the fields in the way that you did, and if it was a SimPEG, if it was a delayed function, it'd give you a delayed function back, but you wouldn't really know. And then if you pass that to like JVec and JTransposVec, it would recompute the fields every single time, because it would recognize, like the JVec and JTVec of simulation object would recognize that the fields were a delayed function. It would call compute on them. So it would call compute on them every single time the JVec and JTransposVec called, which is not really what we kind of want to be doing with these fields, right? We want to be able to compute them. Like if we are going to compute them, we'd like to either compute them once or compute them on the fly if that's what we need. But like, I feel like when we were returning, if we asked for simulation.fields and got a delayed function back, we specifically asked for the fields and called the fields function. We would kind of expect that those would be fields and something that we'd be able to pass on to JVec and JTransposVec, and those would be able to take advantage of it. So that's kind of one of the reasons that I was talking with Dom, that we're moving away from delaying the fields at this point, delaying the fields objects.
Yeah, because we're not using it anyway, right? We're where we delayed it but never never used it
Every time it was being used, it was just being computed anyway.
right away. Yeah.
So we might need to think better about how, if we want to delay the fields, how to delay them, how to properly delay them. Before
Yeah, I still think it's going to be on the misfit function instead, right?
Yeah.
Kind of like at an upper level.
I agree too. I think that we need to take advantage of it at a higher level. So, what else? Yeah, that's all I can think of right now.
Thanks, Joe. Yeah, no, and I totally agree. Removing mumps seems like a reasonable step at this point. We can just do a minor release of PyMat solver and say it's gone. We're going to work on getting it back in a better fashion. But if you were relying on it, use an older version of PyMat solver.
Mm-hmm.
Yeah.
That means PyMat solver will need to be on Anaconda, right?
I think it is.
I believe it is.
Is it already? Yeah. Okay, that's good.
Yeah, kind of forge.
Yeah. Good.
Thibaut.
Yeah, still not much coding. Like I moved from writing revision for a paper to writing a thesis during the weekend. So
Excellent.
just more writing.
Good luck writing. Dieter, do you have anything you'd like to chat about?
Yes. Well, one thing is I'm fighting with the gradient, as you know. But another thing is what might be interesting. I'm as many of you, I think Dom and John as well have talked. They are heavy involved in graphical user interfaces development. And sort of the last 2 weeks, I went the other direction and wrote a lot of terminal-based user interfaces. So within the consortium, there's this joint inversion framework where they use gravity data, magnetic data, tomography inversions, and they all belong to different companies. So they have their central servers and the joint inversion framework that calls out different methods to run those and then combine them again. So all that has to be able to run with commands in the terminal and configuration files. So I learned to how can my code be called with just a command and configuration files, which is interesting because it needs quite some different thinking than when you work in a notebook or in an IPython shell and have everything available. It's kind of a reduction workflow. What are the basic needs and how can I reduce it as much as possible to a few parameters? Yeah, that's it for the moment. I don't know, do you have anything that can be run from SimPEG in a terminal at the moment? Or is that anything that was ever on a to-do list?
So we don't have a command line interface at the moment. Dom has written sort of like driver files and lightweight wrappers that basically you just do like Python run my file.
Yeah.
But I think that this would fit really nicely when we start to think about like a higher level API for SimPEG, is to have basically like mechanisms to make some opinionated choices around mesh design, default parameters, those sorts of things.
And the main thing is meshing, which is, well, yeah.
Yeah, and so with that sort of layer of infrastructure, once we get that in place, then I think it starts to make more sense to like figure out what should our command line interface be. Yeah, because right now it's, we're still a couple steps away from sort of like being able to really just say like run an inversion with this file. Yeah. I think with the properties and the serialization work that we've been doing, it should definitely be getting closer. But yeah, not quite there. I've played around with it though with some other lightweight libraries, but not for SimPEG.
What is actually the time frame at the moment for the simulation branch? Is it weeks, months?
Mm-hmm.
Because I see most of you guys all work in the simulation branch, right? So it's nothing, nobody works with the master anymore.
That's not entirely true, because for instance, SimPEG EM1D is still on is still on master. I have code that still depends on master, so it's a migration.
It's a parallel
still happening
effort. Yeah.
But Joe,
Can I ask, or did you want to say something about simulation branch, Lindsay? Otherwise, I got a question for Dieter, just sort of by the by.
Okay, I was just going to say Joe and I were chatting and sort of the aim. I'll let Joe. You can unveil the aim.
Oh, we were hoping to have it like the aim at this point is by the end of the month. So May 1st will be May Day for simulation.
Great. That's soon.
Go for it. Doug, did you have a question?
So Dieter, can you elaborate just a bit on, you said you got a consortium for joint inversion, a bunch of companies. Can you just elaborate on what that consortium is and who's in it and what the goals are?
Let me put the link in here. So it's basically the project I'm here, which is my postdoc. It's an EU-funded project of, do I find it? It's called GeoSci.xyz. I'm on two computers, that's the problem. The consortium is called GeoSci.xyz, which is for GeoSci.xyz.eu, that's the thing. There's my chat. There you have the basic information. It's an European funded project in a wider maritime research umbrella that sponsored many projects that have anything to do with maritime technologies. And in our project, there are two German companies. It's Tech and Terrasys. They are both, well, more or less in the greater area of Hamburg in Germany. And then involved is GeoMar in Kiel, a German research institute. There is a GFZ Potsdam, also from Germany, and then it's me from TU Delft. And the other four partners, with kind of changing partners, they had already 2 or 3 previous European research projects that were mainly focused on hydrates. They also had more a chemistry focus, and now it's more a geophysical focus. And in this one, we have sort of 3 areas, 3 zones. There's the Black Sea, which are hydrates. There's the Barents Sea, which are oil and gas. And then there's close by Italy, there's kind of deep sea mining sulfides. And the whole idea is just this joint integration of multi-physics, if you want. So they have this, Terrasys has this framework where they run, where they can call different modules. Is it seismic, or is it magnetics, or is it gravity, or is it EM, and integrate them in a joint inversion. A layer-based, I think, inversion framework. And GeoMar does there the CSEM on the, at the moment, mostly on the time domain side, because they also acquire data in the Black Sea, which is time domain CSEM. And I'm looking a bit in the Barents Sea. That data is from EMGS and is frequency domain CSEM data.
So does that mean that each of those groups is acquiring and kind of inverting their data, and then it's somehow all kind of being amalgamated in this superstructure to take advantage of what's been done and try to make another step forward? How does all that work?
Yes, this joint inversion module, GIM, it's a server-based infrastructure. It's kind of that each project partner keeps their IP in a way, so that the framework can run, and then it sends off pings to the other institute or server and tells him, here's a new resistivity model, I want to have a gradient for that. And then this server, like say at GeoMar, is set up that it always listens to incoming new resistivity models, and as soon as there is a new model, it runs one iteration, well, one forward model, it calculates the gradient and writes it back to a file and lets the central server know that there's a new gradient so we can continue. And that happens with each of the methods. Now with my code, that's a bit differently because my code is open source. So we will implement that just in the server where it is. I don't deal with preparing a server and making it ready that it runs. So I just help them to set them up my code.
Okay. Is there like a document that talks about the superstructure of the inversion and how that is being implemented?
That's a good question, and I will ask about that. As I'm just about getting into the inversion and I was mostly with forward modeling so far, I don't know, but I will look into that.
Okay, thank you.
Hey, Devin, do you have any updates you'd like to share?
Yeah, not too much. So I've more or less implemented the recursive solution. So thanks to Joe for giving me some assistance with that. Been doing my, I guess, the adjoint test and looking at the sensitivities, and they're very accurate for the real component. And if I'm working with the sensitivities of apparent resistivity data, but there's something interesting happening with the imaginary component. So I'm gonna need to investigate that. So I'm wondering if there's an operation that's maybe truncating it, or we haven't defined some array to keep enough of the digits. But yeah, something's going on there, but it's almost there. That's pretty much what I'm trying to finish up.
Well, it might.
So once yeah. Oh, go ahead.
I was just going to say, it might be constructive to go through the frequency domain JVEC and JTVEC. The handling of real and imaginary components is a touch subtle, especially in the adjoint. So it might be worth just kind of reading through that code and seeing if there's any insights that you can gain in parallel with what you've done.
All right. Yeah. Well, I guess, yeah, basically what I've done is we formed the sensitivity, but it hasn't been broken into real and imaginary. And so then I'm just taking the real component of that, the sensitivities, as my sensitivity to the real data, and the imaginary component of that for the component of the imaginary sensitivities. So I'm separating them that way, right? Because I don't want to have this sensitivity matrix with imaginary numbers floating around. Otherwise, you're updating the model in the complex plane. So I've done that, but you're saying that maybe it's has something to do with how J transpose VEC is doing the computation. Because I noticed that it's also just JVEC as well. I'm individually looking at the I'm looking at the operation of JVEC, and I'm comparing this also against the whatchamacallit, the finite difference sensitivities.
Okay.
So I'm noticing that there's a discrepancy only in the imaginary component. So I'm a little curious why this is.
Okay. Yeah, I mean, so I guess starting with just looking through the frequency domain code might be helpful. And if you're still running into issues, feel free to ping on Slack, and a couple of us can try and jump in and take a look. These things can be subtle sometimes.
Yeah, it'd be good to know. I'm sure it's one of those. It's just a tiny thing that needs to be found, and then it'll work perfectly. So details. But I guess after that, then I was going to go and turn what I have into some tutorials, because it follows the framework that we're going to be using, and then have those ready for any time we are going to bring this stuff into the base simulation branch.
Sounds good. One thing we can think about, and I'd appreciate Joe's take on this too, when that pull request is ready, is actually if the simulation engine should sit in GeoAnna or if it should sit in SimPEG. And I'm inclined to put it into GeoAnna, because like within SimPEG, we've really sort of focused on sort of the finite volume approaches. but that's something we can think about. I just want to pose it as a question so that when we do like think about merging, we just think that through.
Yeah, it's one of those things. In the EM or in the static resistivity 1D solution, it basically does a recursive solution. Like I think Soggy implemented a recursive solution in there. So it's similar kind of thinking. So it does a recursive solution and then uses those Hankel transforms to transform it afterwards. So yeah, maybe that would be better in GeoAnna as well.
Yeah, we can sketch it out and take a look at the code and see what makes sense. I'm not like convinced one way or the other, but just wanted to put that on the table.
I guess for my next little project, once I complete the 1D MT stuff, I guess Dom, would it be fairly easy for me to pick up the 1D EM code and try to start moving that into simulation branch?
Yeah, that would be fantastic if you want to take this on. Yeah.
Yeah, because I'm motivated to do it because ultimately I want to go and hook up my MT stuff to the pseudo 3D inversion. So I could step in there.
Yeah, and I think that will be super powerful if we can do MT in 1D.
Cool.
With a stitch, right? Stitch 1D.
Yeah, exactly.
Yeah, when you're ready, I would be willing to pitch in and bring the rest of the 1D code as well at the same time. We can create ourselves I guess a new regularization class for the stitch and yeah, just to ask Soggy maybe to help us bring the rest of the EM1D.
Yeah,
Sorry, go ahead.
I was just gonna say, well, it sounds like the class for the EM1D FM problem, and I don't know if you've done EM1D TM as well. Those are living on the base SimPEG branch, so they're using the old syntax, and so really it's just the process of bringing them into simulation.
No, they're not even on SimPEG. They're on the SimPEG EM1D. So it's kind of a separate repo that's tracking master, but there's a little bit more work to be done than just moving it over.
Yeah, that's
fine. I mean, It works, right? We have a way to test it. We just need to rename things and shuffle things around.
Exactly. It doesn't seem like it's super high level. So yeah, I can get on that, and then once we have that stuff in there, then we can go and figure out how we solve the inverse problem or how we create a regularization class for that.
Yeah, and obviously Joe will need your lead on to see where we should append it, where the 1D stuff should go.
Well, I like having like a simulation 1D class within, I guess, the frequency domain method to keep it separate. It's working so much differently than like solving Maxwell's equations in 3D. Doesn't seem like you're able to use much from like a parent class in that. Yeah. So you might as well just keep it separate, and it's a much, I don't know. It seems to keep things organized that way.
So you just joined in, man. Where Dev proposed to start working on the stitched part for the 1D code because he wants to do MT, but it would be a good time to also bring if we can bring in what's on SimPEG EM1D as well at the same time.
Yeah, that sounds great. Yeah, I have a motivation to bringing in SimPEG EM1D to SimPEG.
Yeah, but that's it. Dev and I can pitch at it, and we'll probably just going to ask your review, because it's your code. But I think it's just a matter of like renaming things and re-standardizing.
Yeah, absolutely. Well, like the constraint part was written by you, so.
But yeah, that's it. So we just need to bring the pieces that we need, and then Dev and I will take the lead on it.
Yep, sounds good. Yeah, it should be pretty straightforward. I mean, you can start from just the serial version. Then, if you want to parallelize, you can potentially use the same structure that I have.
And in terms of steps for that, like what are you thinking to first sort of do the simulation refactor and then we think about merging to SimPEG? Does that sound, so like do the simulation refactor in the current repository that it's in? And then?
I was thinking of branching off of base simulation and bringing it in and just starting with getting the forward problem to work and validating that, and then adding stuff to that branch as I go through.
Okay, because the other option, and in some senses, I think that this might be simpler, and Joe, feel free to chime in here too, but is to actually just take the current SimPEG EM1D repo and create a simulation branch on that, and then do the refactoring there, and then we can figure out what the best structure is within SimPEG for a lot of these 1D codes. Joe, I don't know what you're...
Yeah, that would work. I think that would work just fine.
Yeah. So branch off of the current, or I guess, yeah, branch off of the current EM1D repository, make a branch there, work there, try and get that to work independently, then talk about bringing it in later. That's fine.
And then I think will also help, the tests will be faster because you won't be testing all of SimPEG, you'll just be testing SimPEG EM1D. So yeah, hopefully that would simplify some things.
Okay.
Devin?
Yes.
Sorry, I was just looking through the code on there. I was looking at one part where if you're, I think it's like line 227 of your simulation 1D, if it's imaginary, it looks like you're grabbing the real part.
Oh, no, I was messing around with some other stuff later, and then I committed it because I didn't want to lose it before I went to bed, but let's...
Okay, never mind, sorry.
Yeah. But you know, I was working on it late, so I may be a little tired.
One interesting question actually for that MTN version is, so you have two different types of data that you can think of: impedance, real and imaginary, or apparent resistivity and phase.
Yeah.
Kind of like having a bit of motivation to, because just doing 1D seems not very exciting, but if you have a couple of questions like that, which data type is better, or what we need to use, that's, I don't know, that's probably a little bit more interesting. I'm not sure how the 1D code is structured now, but if you can have an option that either you invert real and imaginary or apparent resistivity and phase, that might be helpful.
Yeah,
that's a question for everyone. How much Stitch MT1D have you guys seen around? Have you seen any case studies of using it?
Personally, I've never seen that.
So that's on itself, I think is quite interesting because you know, the MT codes are pretty heavy, and if it's the same that if we can get similar success with the 1D version of the code that we're doing with the EM, I think it has potential.
Yeah, I poked around a little bit and I didn't find it, and so I thought there was definitely space for us to add it, and I also feel that it might work even better than the EM1D FM codes, just because I feel that the data are much more sensitive to what is directly below compared to the EM1D FM. I don't think there's as much horizontal talking with the MT problem as there is in the EM problem.
There is definitely
no.
There's
I think
some,
that,
but
no. No. I mean, if you think about the footprint, it's it's much big. And then I think I'm a little bit pessimistic because you probably think the other way, because 1DMT is such a cheap solution, and if never, if other people haven't done that, then I don't know. That's
You
probably
definitely have it in WingLink from Schlumberger. They have it for EM and for MT and combined, that you do quick 1D inversions and you stitch them together, or 2D inversions and stitch them together. So it's
Right.
definitely used in the industry. So I do think it works fine. I've seen many results from that, but that's all WingLink.
but
Yeah, it's
my
also fairly, I mean, I think in the scheme of things, it's just like that is something that used to be done in like the 1970s type of version, early 1980s. And then the default went to the 2D because the 2D algorithms kind of came out. They were actually moderately robust, so you could get both TE and TM in versions. And that's basically where that default lays. I think, I mean, there definitely are, as Dieter says, stitched 1D algorithms around, but yeah, they haven't really been utilized since the 2D became so prevalent.
Mobile MT, their in-house inversion is 1D stitched. Or Expert Air, I can't remember what they go by all the time. But
yeah, I don't know that, because I think you'll have even like a hard time even fitting the data if you just simply use 1D code. So you need a lot of other processing, like other pre-processing, to actually use 1D code to invert actual MT data. So yeah, I think the context is a bit different from the airborne here.
Mm-hmm.
Yeah, so I'm not quite sure
What
how
might be
effective it could be.
interesting for the question you asked, talking about impedance.
TE and TM modes are pretty much similar. Then inverting them in 1D should give you a pretty reasonable answer. But if they start to diverge, then not really sure what you get out. Actually, at that point, doing 1D inversion for tensor invariance of the MP impedance seems to have been a bit more robust entity to use. And frankly, if we're going to stitch together 1D MT, then maybe one should use the determinant of the impedance tensor as data. I think there's something to be looked at there.
I guess, yeah, I wasn't proposing that we would be inverting the ZXY and ZYX, because yeah, I think I would have lots of trouble fitting the data in that case. I would almost propose that you'd do something maybe like inverting the XY and then inverting the YX separately, or maybe seeing if you got different models from those two components of the impedance tensor. But I would think you'd be able to fit the data if you did it that way.
We'll see. Just code it and then we'll do it.
Coding up is, I mean, it's relatively simple. So I mean, like, I wouldn't just go ahead. Yeah, I think
I would definitely ask Kerry Key, or at least read the Mari to DM manual, because he has all the possible components you can use for inversion, and through his Mari work, I think he has quite a lot of knowledge about how to jointly invert EM and MT. And I remember that I read some notes, what works fine and what doesn't work that fine. So it might be worth writing him an email. He's quite open to give away what he knows, to share what he knows about those things.
The other thing is, if it works well, it could also be a good initial model and reference models for 3D inversions too.
Well,
yeah, something like that. Yep.
There's other parts of it too, or at least talking to some of the people who are trying to get into using the MT stuff, is their desire to try and invert all of the frequencies at once, which I've really said that that's crazy and you can't be doing this. But if you do the stitched 1D inversion and then you start to get a sense at the depth at which your target is, the frequencies at which are sensitive to that target, then you get a little bit of an idea of the scale of the problem that you really want to solve before you move to 3D. And I think that has lots of value.
Mm-hmm.
Nice.
Dougie, did you have any updates or things you'd like to share?
I'm I'm mostly working on airborne data. That's actually full time. We're interested in what they call Corcoran clay. So it's like a very extensive unit in Central Valley of California. So it's a fairly thin clay layer. So if you just do a smooth inversion, you have like 100-meter thick conductive layer, but that's not truth. So yeah, I'm just like starting to use what prior information that I can use. So I was thinking about using sparse inversion. But the problem in EM, your model is actually not sparse. So because geology is complicated. So you can simply use what them used to do, like just putting a 0 as like a reference model. So you need to come up with like a pretty good background model and then force the sparsity to get that like a thin clay bed or something. Yeah, so that's what I'm mainly working on. Yeah, also there are like sometimes airborne survey has done multiple times in a couple of years. So you're gonna get actually like a couple of different systems covering the same area with different sampling, different density of the sampling. People don't actually invert them together usually. So I was playing with, like can we actually invert them together, get a common resistivity model. So structure is already, all of the structure is developed. So I'm mostly playing with what we could do for a given data set. So.
Yeah, much leveling to be done between the systems?
Not really. So yeah, I'm basically inverting them together, like using this spatial constraints. So I'm not like it's not an exact joint inversion because model has a different space, but by putting a constraint in between, you can still force the like the model to be very similar. I thought that's actually a good idea, but then it's actually quite applicable for various airborne systems. So
yeah, that makes sense. Yeah, because they're never going to overlap, right? So
right, then you could like combine frequency domain, time domain, or ground system, airborne system, and just dump into like a single constraint and invert all of them together to get a common resistive model. Anyway, so that's what I'm mostly working on.
Yeah, I'm also working on the same thing, right? And I agree. The sparsity on the model itself doesn't make too much sense if you don't have like if your reference is not like a uniform. So like on the gradients, doing it on a gradient makes sense. It's kind of nice to be able to get some flat features, but
so that's what typically done in EM problem. So what they call L1 norm is usually on the gradient. So, but like that doesn't really help, right? Like well, it helps to put a boundary on it, but you're not really forcing the sparsity of the model, which is a little bit different. Yes, I'm looking forward to. So I think people haven't done that for the EM problem a lot. So I mean, I think people never done that. I think putting actual sparsity on a model distribution. So yeah, I'm looking forward to kind of apply that and see if, how well we can recover the thickness of the clay.
Cool. Well, I'm excited to see what you come up with, Sagi. Doug, did you have any updates?
No, not really. I was really pleased actually to hear about this Guitaro Gym consortium, which I hadn't heard of before. So it'd be really interesting to kind of see, what scope of problems they're attempting to do, and just sort of how the superstructure of all of that is working. So yeah, thanks for that. But no, I don't have anything. We've been kind of consumed with SCG abstracts and stuff like that, which that's another meeting that might not get held these days. We'll see.
Well, I'll share a couple updates. I've been working on the example that I owe Dieter with the block models. So I've been playing around actually quite a bit with the Octree meshes, and also playing around with like so having a tensor mesh underlie the Octree mesh, which is pretty cool that all of that is actually in place, and that was pretty trivial to do, is to basically take your coarse padding cells and just say, I really don't care what's going on here. I just want to stretch them out so that I'm satisfying my boundary conditions. So I'm still sort of playing around with that, trying to get a sense of how hard I can push it before, things start to numerically break and things like that. So hopefully I'll have a couple notebooks that I can share in, a week or so's time. So that's one thing that's been on the list.
What system are you applying it to? Did you say? Did I miss it? Did I miss what system you're applying it to? Or
To frequency domain EM.
Okay.
Yeah. Yeah, so playing with that. And then the other thing to share, I guess, well, Joe and I chatted earlier this week just about the simulation and how to bring that in and do that well. So we're working on starting a blog post that we can use to just kind of announce what's changed and be like a high level overview. And then we can make sure the release notes are pretty detailed. But with that, one of the things I'm gonna try and do is sketch out basically what is the new SimPEG framework. Because our old sketch of sort of the pairing of the survey and the problem no longer holds. So I'll send around some images. I mean, the interesting thing, like that image has served us really well. If you really dive into it, it isn't actually like fully accurate, and that's fine. So I think what we want to try and do is like come up with like what is a good conceptual structure to provide folks with. So if you actually have something in mind and just want to like sketch it in a notebook and take a screenshot or take a picture and send it along, it would actually be pretty cool to get a sense of how people are, how you're conceptually thinking about SimPEG. And we can try and consolidate that into actually like one single framework diagram. So feel free to sketch and send pictures. Yeah, and so I think that's basically it from my end. Does anyone else have questions or things thoughts you'd like to bring up?
That's like that conceptual structure is something like related to current simulation branch.
Yeah. So basically, like if we replace the figure that is the main one on the SimPEG website in the SimPEG paper, like what's the new version of that figure?
Right. Okay. Yeah. Wow. So we're gonna change that. It's exciting.
Big move, and I see Liz is asking who uses paper anymore. That's fair. Digital paper.
These are just weird comments I hear when I walk into the room and I'm like, paper? What's that? Anyway, goodbye.
Oh, so we put together an SCG abstract for DC code. Well, like the motivation was helping this GWB project. But I thought like it's probably worthwhile to actually write a paper about that code. Mm-hmm. So I think now it's actually quite matured. Although we have like some things on parallelization stuff, but I think it's already actually in good shape. And just extending, and then actually that GWB motivation is good. And we also got kind of numerical support that we can handle 1D, 2D, and 3D and have a relatively good example related to hydrogeology application. So yeah, I thought it's probably worthwhile to write as a paper.
Where would you want to send that?
I'm not sure at the moment.
Because just like the initial thought is if we do send it to geophysics, then we can actually take exactly the content that was in the abstract, right, and that out, which is easier, but doesn't have to be the case.
No, actually, I think I wouldn't mind actually something to geophysics.
Yeah, we can definitely
Yeah.
flesh out a lot more of the details and underline what things
Right.
are.
So yeah, exactly. So I thought this is an opportunity to actually write down all the details, that the equations and stuff, because we don't really have a great documentation about how things are working.
Yeah.
So yeah, writing a paper seems a good motivation to actually archive the theory behind and discretization and stuff.
For sure. Well, feel free to just copy paste that abstract into a new Google Doc and ping everyone, and yeah, we can jump in and do that. That would be great to get a paper out of all of that work.
Mhm.
Okay, that's great.
Joe, I'd like to get back into the sensitivities for the MT problem, and you said you kind of had a start on it. Do you think I can take it from there?
Yeah, hold on. I think I had stashed those changes, and I forgot to put them back on.
Oh, okay, fair enough.
I'll get them up there. Yep.
Okay, cool. Yeah, I could tackle that if.
I think I'll just drop them into your simulation MT branch.
Oh, okay.
That'll probably be a good spot for them because haven't really quite completely tested them out yet. Like I had them working on the old style on the master branch. I had it working off the master branch, and I just kind of copy pasted and renamed what I thought needed to be renamed and went forward with it.
Nice. Yeah, that'd be great. Yeah, be cool.
Okay.
Could
Thanks.
anyone give an executive summary of last Thursday's MT meeting? What was the main outcome? What is the way forward?
Did you record it, Lindsay?
I did, yes. So we have,
okay.
if you want to watch the 2-hour version, but we can quick notes. Is we spent a bit of time, actually I think we took decent notes. Let me just see if I have those handy. Not off. Oh yeah, no, I do have them in the.
Well, Devin opened all these on GitHub. I saw that kind of the projects. What are they called?
Yeah, so Devin started putting that together. So we walked through sort of what are some of the big changes we would like to see. So structurally, things like right now, actually the natural source EM has its own simulation, which is distinct from the frequency domain, which doesn't really need to be the case, but there's some assumptions in the frequency domain code that just made it easier with the development to sort of have them as separate things. So for example, the source giving back 2 vectors when we're doing 3D because we need both polarizations for any natural source simulation. So just those little style of assumptions, at least for initial development, it was easier to do that on its own. But it would be nice to actually basically throw away the NSEM simulation, like the way it calculates the fields, and really have the natural source EM only be in the survey, the sources and the receivers. Mm-hmm. Then with that, we also talked a bit about boundary conditions. And so having right now, the only implementation we have is a primary secondary approach. So it would be nice to get the boundary conditions implemented so that we can play around with that a bit more. So that'll drive hopefully actually some development in discretize if we can abstract it well enough. And then I'm just looking at the notes. We identified a few different examples to work from. So we'll start with the L block model that the GIF codes have been tested against quite extensively. And then there's a number of us who have a data set in mind that we want to work with. And so we'll sort of bring those in. Yeah, are there other things that folks, Siyasagi, wanted to highlight from that meeting?
I think it was more the same with parallelization. We talked about for a while. Yeah.
Okay, cool. Yeah, just thought I asked.
Yeah. It has been a while already. It's kind of behind far in my head, but yeah, we'll have to look at it. Nothing super concrete.
that it moves forward, because it came up on Slack, I think, since in the last, I don't know, 2-3 years that I remember. Every couple of months somebody was asking,
Yeah.
how's the MT going? And then there's someone posted a notebook and then it died out. And so,
yeah. One other thing that I'd appreciate your thoughts on too, just to even keep on the back burner. So some of that work is part of the Jupiter Meets the Earth project. And so we're trying to also think of things within the Jupiter ecosystem that like would be advantageous to have when working with inversion codes. So things like, one of the things that I think would be pretty cool is Joe Hammond hooked up Czar to a Redis server. So what you can actually do is be like looking at results or looking at pieces of the computation that we typically wouldn't have access to. So something like we could watch how the gradients change at each iteration and things like that, like looking at some of these intermediate results that you throw away. But if there's other things that come up and like you have an idea of, it would be great to have X, it would be really helpful to get input from others so we can develop some cool things that serve all of us. So.
And because you mentioned boundary condition, has anyone in SimPEG ever looked at a perfectly matched layer boundary condition? Something that, yeah, sometimes you read it these days more in Geo rather. I see some stuff in EM, but I never really looked into it. So that you would have like a very absorbing boundary and you wouldn't have had to go very far away. Was that ever a topic?
I don't think any of us have looked into that yet.
Or I know that the EMGS code in EM, they have a boundary condition where they basically just stop at the air interface. And I actually don't know how they do it exactly. I would have to look in. So yeah, there are kind of other boundary conditions that would be interesting, but I think they would be probably an entirely new PhD project. So just thinking about it.
Yeah, would be fun. Cool. Okay, does anyone have anything else you'd like to bring up? No? All right, well, thanks everyone, and we'll see you next week.
See you online and next weekend. Bye.
See you next week.
Bye, guys.
Yeah, bye.
And Doug, you wanted to chat about things.
Yeah, how about in like a half an hour or something? Does that work?
Quite possibly. I need to